Hey y'all, it's me, Santa Claus, also known as Logarithmic Spiral Fan number 27. Today we got an AP classroom work problem here. So this one is one end of a string of negligible mass wrapped around a pulley and the other end is connected to a hanging block of mass m. A motor exerts a torque of magnitude t on the pulley and causes it to rotate in the clockwise direction, lifting the block. The radius of the pulley is r and the rotational inertia of the pulley is I. Which of the following equations accurately represents the scenario and can be used to solve for the angular acceleration of the pulley? So, I didn't actually solve this one on my own. It was really difficult. I had to get one of my elves to help me out with solving it. So, and he kind of pointed it out. So we're gonna first by taking a look at this block here. So if we look here, there's two forces acting on the block. We have the tension force of the spring, which I'm just gonna call F of t. And we have the downwards force of gravity, which we're just going to call mg, because that's allowed, because that's a physical constant, so they're not going to scream at us. So here's what we're going to do. We're going to write our NSL, our Newton's second law, which, if we remember correctly from our amazing teachers of AP Physics, net force is equal to mass times acceleration. So the net force would be Ft and mg added. But we're going to have to give one of these a negative sign because that's how math works. I mean, that's just how physics works, I guess. So we're going to give mg the negative sign because we're going to say up is positive because that's the way it's being pulled, because that just makes our math easier. So we can say Ft minus mg is equal to mass times acceleration. So we get Ft equals mg plus ma. So now what we can do is actually factor out that m, and we get ft is equal to m times g plus a. So we're gonna keep this for later, but we don't want to clog up our screen. So we're gonna do, okay, that's refusing to delete. Cool. Santa Claus is gonna have to get some help with that. So ft is equal to m times g plus a. So let's go back to what our question is asking for. It's asking for our angular acceleration. So, I mean, the next logical step would be we need to get the torque equation for the spinny thing, whatever you want to call it. So if we examine this, there's two torques acting on this. You have the torque of the tension, which is pulling down on it, and then you have the rotation, the t, which is pulling it along. So because it's going the direction, we're going to say that. So I don't know how you draw an FBD for these. So we're going to just say the sine is equal to 90, just because I don't feel like explaining it. Just trust me, bro. I'm Santa Claus. You'll be on the naughty list if you don't listen. So we're going to say we're going to write out our net torque equation, which is literally just a ripoff of Newton's second law. So we're just going to write this. We have we have the torque of the engine, which I know it says it somewhere. Yeah, the torque of magnitude t. And we also have another force. We're saying torque is positive because it's pulling in the direction. And we also have the tension force. But the thing is, we can't just say the tension force because, that's not torque. So we can use our great friend RF sine theta. So sine theta right here doesn't matter. We're just going to say that's equal to 1. So our R is R. Oh my god. Dude, my can of Monster is screaming at me. So it's R, and then our F is, our F is right here, isn't it? Yeah. So R. So for no particular reason, it's totally not in one of the answer choices. That's totally not the reason. We're going to rewrite this as mg plus a times r. Okay, so that's our torque for Ft. So now we have m times, so minus mg plus a times r. Okay, hold on. Let me open up Google. So, hold on, ignore this. We have to finish off the equation. This is equal to our inertia times the angular acceleration, which, angular acceleration, that's what we're solving for. Wow. So, let's take a little look-see over at our answer choices now. And you look at that. T minus m. That is not... Oh, ignore everything I just told you. Okay, so as we... Ignore that. That didn't happen. So as we know... so we're just going to write a little equation for y'all real quick. So you have acceleration tangential. Tangential acceleration is equal to alpha times r. So we can rewrite so AT, that's literally just regular A. We don't need to write this as translational. That was supposed to be an alpha. So we can rewrite this, ignore this A right here. This A doesn't exist. You see this A? No, you don't. That A isn't there. You're lying to yourself. So we're just gonna go back a little. Alpha r times r. Dude, my monster is screaming at me. Okay, so that's equal to inertia times angular acceleration. Now let's actually look. Okay, t minus m times angular acceleration r plus g times r equals inertia times alpha. What do you know? That's our answer. We did it.